So we're picking up 9.1. Now we're on day 2, starting with number 8. So we are told that each ordered pair is from an inverse variation. We are asked to find the constant of variation. So inverse variations, general form would be helpful for us to remember. For inverse variation, it's going to be y equals, if you need a refresher, you could flip back to the first page of your notes. K over x. And when they solved that equation for k, what do we get? K equals what? xy. So we would multiply both sides by the x to get the k alone. So if all they're asking us for is the constant of variation, which letter is that? K. K is our constant of variation. Then it might be most useful to use this equation on these problems. So we're told from the beginning that it's inverse variation. These are the formulas that apply. All they want is the constant of variation. They didn't ask us to write a model or a function for the model. So on letter A, K equals what times what? 0.9 times 4. Remember, when we're given ordered pairs, they're usually in the order x comma y. So we just have to plug those in. And what do we get for k on letter A? 3.6. That's all there is to it. Now, it gets a little bit trickier on parts B and C because they threw in radicals. But really, it's no different. K is equal to what times what? Square root of 2 times square root of 18. When we multiply square roots together, we can multiply those numbers together and keep them under a radical. So it would be radical or square root 36. Lucky for us, we can take the square root of 36 and we end up with 6. So k equals 6 for letter B, number B. Questions about letter B? Okay, letter C, same process. Still inverse variation, still trying to find our constant. So k equals what times what? Square root of 8 times square root of 32. When we multiply those together, we get the square root of 256. And the square root of 256 is 16. So k equals 16. Questions about finding the constant of variation from those problems? Ready to move on to number 9? Okay, they make them a little more interesting on these. So now each pair of values is from a direct variation, and we are asked to find the missing value. So now it's just a little bit more than finding k. We're going to have to find k, write an equation, use an equation. So we're going to just do these one at a time. I'm just going to take letter B away for a minute so we can focus on that first one. We are going to have to find k, write an equation, I'm going to call it EQ for short, and then use that equation. Similar to how we were doing things yesterday, except they gave us the information in a bit more of a condensed format. So to find k, we first need to know our general form for an equation. So if we are doing direct variation, Y equals k times x. Good. So remember, for direct variation, k and x get multiplied. For inverse, k and x get divided. All right, so we've got our general form. In order to find k, we need to use the pair where we know both x and y, so we can substitute them in. So what am I going to plug in for y? 5 equals, I don't know k, but x is 2. To get k alone, yep, divide both sides by 2. So k equals 5/2. If you really want to write it as 2.5, that's not wrong. I just like to leave mine as an improper fraction. Questions about finding k? When we write an equation for these, what's the only thing that gets plugged in?
K.
The k. Only the k. Everything else stays. So y equals 5/2 times x. Now that I wrote my equation, I'm going to use that equation. So in order to fill in this last set of parentheses, this last ordered pair, I have to use the equation I just wrote. 4 times 5/2, because I don't know y, so y is left as y for now, equals 5/2 times, and for x I'm going to plug a 4. So we get 10. So 5 times 4 is 20, divided by 2 is 10. So that's what they were wanting us to find. We just had to take a couple steps to get there. Do we have questions about that process? Okay, I want you to try using the same process on letter B, except what's different about letter B from letter A? What is it? Letter B is still direct on number 9, but what are we finding?
Okay.
We're going to find an x instead of finding a y. Do we see that on letter B for number 9? If I bring that back up here, they have us finding an x instead. So our process will be the same. Find k, write an equation, use the equation. It's just that we're looking for an x instead of a y in the end. So give that a try. We'll go over what we got in just a minute. On 9b, what did we plug in for y? 5 equals k times, what went in for x? 9. To get k alone, divide by 9. And again, I would highly recommend just leaving these as fractions. I don't even know if this one comes out to a nice decimal, so I would just leave it alone. Then we write an equation, which means we're only plugging in k. So y equals, good, 5/9 x. Finally, we are going to use that equation. So this gets a little strange. When we use our equation, what are we plugging in for y?
3.
The 3. So 3 equals 5/9 x. Now to get x alone, there are a couple different things we could do. If you want, you could write this as 5x over 9. If that helps, you can put the x in the numerator. So if we were to do that, first of all, let me just write up here why we're allowed to do that. 5/9 times x, I could put the x over a 1, and then when we multiply straight across the top, we get 5x. Straight across the bottom is a 9. So if it helps to put the x in the numerator, that might make it more obvious what to do next. What should we do? You can put the 3 over a 1, but what do we need to do to both sides? Somebody said it. Multiply by 9. That'll get rid of our denominator there. Sorry, I made an extra extra mark. There we go. So we have 27 equals 5x, and then we need to divide by 5. So x equals 27 over 5 is fine with me. That one you probably could get an okay decimal. You wouldn't have to round it, but I would just leave it as an improper fraction. Makes less work. So on number 10, we're switching over to inverse variation. So a good reminder, my general form is y equals k over x. If you would like to use the k equals x times y, you can do that. So, same steps really. We're going to find k. We're going to write an equation. We are going to then use that equation. To find k, I need to use the pair where I know both my x and my y right away. So my first y is 5. My first x is 2. What do I end up getting for k? 10. Either way you set it up, the way I did it or using the other one, you should get k to equal 10. When we write an equation, the only thing we plug in is k. I know I'm probably getting repetitive. However, when we did variation back in chapter 2, this seemed to be one of the most challenging things, was being able to write an equation. We only plug in the k, we leave the other variables alone. Finally, we need to use that equation. So if we're focusing on that first problem, problem A, what am I putting in for y? A y. We don't have y yet. That's what we're trying to find. Equals 10 over 4. Now, if you put in your calculator 10 divided by 4 and you get a decimal, that's fine. If you just simplify that fraction, it's fine. What do we get? 2.5 or 5 over 2. Same thing. I would accept either of those answers. If you're going to leave it as a fraction, though, you do need to simplify it to the 5/2. Questions, concerns? Okay, go ahead and try letter B again. Again, on letter B, we're looking for x instead of y, but we are still using inverse variation. All right, first up, we had to find k, which means we use our ordered pair that we already know, all parts of it. What's my y? 5. Oop, wrong pen. 5 equals k over 9. To get k, we have to multiply by 9. So we get k to be 45. When we write an equation, we only sub in k. Y equals 45 over x. Beautiful. Next, we use our equation that we just wrote. What am I plugging in for y? 3 equals 45 over x. Now, I heard some discussion about how exactly this works. So one thing that helps some people is if both sides are written as a fraction. So we could put the 3 over a 1. Whether or not you do that, your next step should look the same. So if we put it over a 1, we think about it like cross multiplying. 3 times x is 3x equals 45. Now, if you don't need to do the over 1 to be able to know you got to multiply the x over, that's fine. You don't have to show me the over 1. But for some people, it helps to see it as a proportion. But we still need to get x alone, so we're going to divide 3, x equals 15. Beautiful. 15 is not a big number. Remember, it's not a big number unless it's a big paycheck, and 15 would be a very sad paycheck. The volume of a square pyramid with congruent edges varies directly as the cube of the length of an edge. So before we even keep going, I would like to set up a very generic equation that we could use. So what letter do you think we want to use for volume?
V.
V. So the volume varies directly. So yes, V equals, if it's direct variation, I know I'm going to need a constant, which we usually call K, and we usually multiply it to whatever it varies directly as. So varies directly as the cube of the length of an edge. X to the third. So whatever you want to use as your variable. If you want to use L for length, E for edge, X because we use it all the time, whatever your variable is there, it's got to get cubed. And I would maybe make a note that we're using X to represent the length, and if you need or want to, V represents our volume. Questions on just translating that first sentence into a generic equation? Okay, they put a lot of extra words in there, but we just gotta, like the whole square pyramid part, I don't know that we really care a whole lot about the fact that it's a square pyramid, but there it is. So it says the volume of a square pyramid with edge length 4. So what variable would that go in for? Edge length is X. Is 32 root 2 over 3. So that is the volume. So this would go in for V. I just like to make little notes as I'm writing. Find the formula for the volume of a square pyramid with congruent edges. So if we're finding the formula, that means that we first have to find K, that's always our first step, and then write an equation. We don't have to use our equation on this one because they didn't give us any other numbers. They didn't then say find the volume if the edge length is blank. So find K, step 1, and then we will write an equation, step 2. Or write a formula, same thing. Formula, function, equation, they all look very similar to us on these problems. If I'm finding K, what is going in for V, my volume? 32 root 2 over 3 equals, I don't know K, times my volume is 4, and that gets cubed. I'm going to erase my right equation for just a minute so I've got some space over here. All right, it's not looking pretty, but it's okay. We can do this. So 32 root 2 over 3 equals K times, what is 4 cubed?
64.
64. 4 times 4 times 4. 16 times 4, 64. I would agree. Then we have to get K alone. So we have to divide both sides by 64. If you would rather think about that as multiplying by the reciprocal, 1 over 64 on both sides, it's the same thing. So it might help to write it as 1 over 64 being multiplied instead of trying to add another division bar on there. Okay, remember, instead of dividing by a fraction, we could multiply by the reciprocal. So 1 over 64 is the reciprocal of 64. All right, then over here, our 64s are canceling out so that we just have a K. What could we cross cancel on the left side to make our lives a little bit easier? 64 with the 32. So 64 is going to change into a 2. Okay, we could divide both of these by 32. 64 divided by 32 is 2. 32 divided by 32 is 1. So now I just have 1 times 1 root 2. What is that really? Just 1 root 2, or you can just write it as root 2 over 2 times 3? 6. Now let's pause. Do we have questions about how we came up with our k? Nothing? Warm, fuzzy feelings? Yeah. Now we still have to write the formula, or write our equation, which means the only thing we plug in is k. So we're going back to our general form we got over here. And we say v equals square root of 2 over 6 times x cubed. Now again, if you want to put the x cubed in the numerator, you can. Or if you just want it to kind of be out next to it, that's also fine. That's it. They didn't ask us to use that equation to find another volume or find another length, so we can just leave it alone.